OC 495. All right, this is extra. Stop. We've been practicing the Rhino Grasshopper script, right, for geometry, um, the build up. So this is the specifically for geometry build up for the ETABS, which is the building oriented, right? Something that high rise building or some complex these days, even the high rise building has a very interesting geometry shape. Each floor can be tapered and each floor plate changes. So now question is how we're gonna build this geometry manually or something using Rhino Grasshopper tool that you can maximize in the product abilities. So I've been encouraged every my students to learn this kind of at least tool so that for future when you're running into something complex geometry or building and parametric type of works task, I want you to develop further based upon some you learn during this class. All right, so here I just create, I will show you the one of kind. There maybe a lot of different approaches, but let me start out from here from the scratch. So I already shared this run a grasshopper stuff. Let me just start it from the zero. So this is grasshopper the script that I set with some the curve. That's an example. So let me start with the front. So what I'm gonna do, I'm gonna draw some random curve by clicking this curve. Let me see. So this is 500. I could draw something like that, right? So this is curve, right? So this curve, I'm gonna just link here. So what I did, and let me show you in 3D. So that curve, I just pull a array, and this time as I did 8 times, but you could slide this 3 times, 4 times. All right, 5 times. Okay, maybe 5 times seems interesting. All right, so I generate this kind of using polar array. Obviously, copy around 360 degrees 5 times, but I make surface by using loft. So once I create this surface, which I assume this is maybe you're given from the architect, they are building and the mesh is something similar to this, so you can kind of use other step, but since we don't have a geometry, I randomly choose and showing some example. The one thing, okay, this nose, okay, so I draw the one the curve and using polar array and make surface. Now second one is for the ETABS we need to define the floor elevation. So here you see that the floor elevation starting 0 to 110. Maybe I'll try to add 120. No. So you see that this contour can trace out, right, all the polygon, right? There's a polygon, so which we're gonna use a polygon for our the geometry. All right, but typically when you have this polygon as is an edge of a slab, we need to offset our column. It could be always parametric, but this is just an example so that I'll try to show you all what I did, right? So this is a contour polygon, and okay, I did some divide the curve and get the polyline. So this contour, I'll just rearrange. First I divide that curve and restructure to the polyline. So this polyline, I'm trying to export later. All right. Now, since I know geometry edge of slab, I offset that curve. So using offset, how much I offset by 2 feet, and those once I offset, right, this there's the curve has been offset by 2 feet and divided and restructure vertical columns, right? You see that all the column. So also I use polyline by using flip matrix. This is more data structure. When you start with a series of curve, but you need to flip the data structure so that and we should be able to draw the column. Now question is the column line element, we cannot use polyline, so I explore it, build the curve. So again, the polyline is working for slab, right? And the line curve is segmented line we need for column and beam. Okay, let's say, so where is another beam? I said, okay, so this one is this. Okay, here. So what I'm gonna do, so I'm gonna bake this polyline for the slab into layer 1, right? And then column, you see that column, I select, I bake to layer 2, and just this, the beam, which tying the column, I'm gonna bake into 3. So this is all line and polyline. I'm gonna turn off here. So this is all my original reference line. I'm gonna turn off. I don't have to export this, so I'm gonna hide it, right? So what I see I back is all the edge of slab and column and beam line as my reference line. So most of cases, the most time consuming work is get the slab edge geometry. So I'm gonna select all and export into DXF file. So this is, let's say, Lino, Grasshopper, and ETABS exercise. Right? I'm gonna export to DXF. My unit is, I think I use a fit. So let's check. So I export. Right here, fit, right? And open the ETABS. I should practice a little bit, just make sure. So let's say you're gonna open new ETABS, but you're gonna open with Imperial or everything fit. So open the new Windows, right? And then import DXF file of 3D. So I'm gonna import current DXF file. So I'm gonna bring these 3 layers. I use a fit, so I'm gonna choose fit. See that they register since I defined the elevation. Those data actually interpreted and imported to the ETABS. So let's say, oh, there is something going on. Okay, let me see. Yeah, I think it's okay. Yeah, so let me just put it this a little bit side by side. So, right, and this. Right, so I think again I haven't started the floor framing layout, but let me just double check whether everything's correctly. Maybe I have to. I have actually I baked 2 plate together, so may have to delete the interior or keep the exterior. Delete the exterior one, but you see that somehow I baked 2 plate. So you could see that the floor plate it came and the column. Okay, let me just bring it back. Yep, the column was imported, so segmented. The one thing I want you to notice and understand, ETABS is all the vertical element when it is straight up, that is column, but it's the member is slanted like this, slope this, is they treat as diagonal brace. So I'm gonna just turn up the brace. It's gonna turn up the brace, right? It's not column. So I know that physically we consider as a column, but in numerically ETABS separated. Only vertical straight is treated and grouped as a column. The slope things was treated as a brace. So I want you to make sure you understand that. So this complex geometry, the most of time consuming is this geometry for the slab. So now engineer typically based upon this geometry, right? You could start with the beam framing. Now maximize it. Depends on overall layout. You can. Oh, Oh, I didn't bring the beam yet. Okay, beam should be there. I didn't maybe export it. Okay, beam supposed to be there, but oh, I maybe export wrong layer. So maybe I can do this again. All right, I export all again. So I'm gonna import latest file. So the slab element should be polyline, and the column and beam should be unit. Oh, I choose the wrong unit. Okay, import 3D file. Okay, I have to choose. So just save it. So so the polylines, it is automatically recognized as slab, but line for the column and the beam supposed to recognize a beam. I may have to enclose the entire polyline. Okay, so there is some missing, but obviously what I did. So let me just show you again. So what I tried to do here, polyline, I have to close it. One thing is missing. So I think it's polyline set true. Okay. So here polyline, I'm gonna bake it. Okay, so this is all polyline, right? This is polyline. And the column, I'm gonna bake it separately. So okay, but this is segmented, right? And the beam also should be segmented. Okay, so this is segmented, right? Okay, so I'm gonna export the XF file. Okay, and then ETABS. Okay, delete it. I'm gonna import the XF file again. Choose fit and choose layer. Okay, so I import all the slab and column and beams. Okay, this is the end of the class. Thank you.